Hello everyone, welcome to my Let's Live Physics YouTube program. My name is Dr. Tashada Tashomalamu. This program focuses on physics questions taken from the Ethiopian Senior Secondary School Living Certificate examination. It is designed to help students understand the basic concepts of physics for each topic covered in the question and to enhance their problem-solving skills. For today, let us start with a question taken from the 2023 GC or 2015 EC physics exam. A given question may be based on the various physics topics, such as mechanics, oscillation and mechanical wave, thermodynamics, electricity and magnetism, light and optics, or modern physics. Now, let us see a question which is taken from 2023. The question says, which one of the following statement does not describe coherent light or interference of coherent light? A, coherent light waves have the same frequency and wavelengths. B, in order for two waves to be coherent, they must be the same type of wave. C, sustainable interference pattern can be formed by two waves with variable phase difference. D, two waves which maintain constant phase relationship can produce sustained interference. Before we see the answer to these questions, let us review the basic concepts of physics. As you know, this question is taken from optics or waves and optics topic. Now, let us see what the meaning of light is first. As you know, light is a form of energy that is visible to the human eye. በሰው ልጆች አይን የሚታይ የኢነርጂ ፎርም ምን ብለን እንጠራለን? ብርሃን ወይም ደግሞ ላይት ብለን እንጠራለን ማለት ነው። So again, we can say that light is electromagnetic radiation that exhibit both wave and particle nature. ብርሃን ስንል እንግዲህ በፊዚክስ ነገሮችን በምናጠናበት ወቅት የነገሮችን ጠባይ ወይ ዌቭ ነው ብለን ልናጠና እንችላለን፣ ካልሆነ ደግሞ ፓርቲክል ነው ብለን ልናጠና እንችላለን። ነገር ግን ወደ ብርሃን ስንመጣ ሁለቱንም ጸባያት ያካትታል። ፊዚክሱ እንደሚነግረን light has both wave and particle nature. Now let us see the key properties of light. The first property of light is wave nature. When we are talking about wave nature, the wave nature of light can be described by using four different terms. The first one is reflection. When we are talking about reflection, reflection is nothing but it is the bouncing back of light when it strikes a smooth surface. The second property of a wave nature of light is refraction. Refraction is nothing, the bending of light as it travels from one medium to another medium. The third property of the wave nature of light is diffraction. Diffraction is the spreading of light when it encounters an obstacle. And the last wave nature of light is interference. Interference means nothing but it is the combination of two or more waves to produce a resultant wave. Now, in order to make clear the wave properties of nature, let me show you simulation. The simulation will help you to understand what reflection is, what refraction is, what diffraction is, and what interference is. The simulation displayed on the screen help us understand reflection and refraction. It consists of different graphical user interface components. The interface on the right-hand side allows us to adjust the medium for the propagation of light wave. That means these two interfaces, which are found on the right side of the display, help us to adjust the medium for the propagation of the light wave. The interfaces in the top left part of the display enable us to generate light as either a ray or a wavefront. For this lesson, the medium shown in white is air with an index of refraction of 1. That means this part, the white part of the display represents air medium and its index of refraction is 1. The medium shown in the light blue is water with an index of refraction of 1.33. That means this part, the light blue color on the display, shows a medium of water, and its index of refraction is 1.33. The continuous line, this continuous line that separate the white part and the blue part, help us a boundary. Again, the broken line, the broken vertical line, this line, that means this line, the broken vertical line is called a normal line, which helps measure the magnitude of bending when light changes its material medium. Now, let me show you the simulation, because this simulation help us to understand reflection and refraction. Now here we have a light source. When I push the button on, the light is emitted from the source and it travels from air to water. When it travels from air to water, some part of the light is reflected at the boundary, or that means it bounced back from the boundary, and some part is transmitted into water and bent towards the normal. Therefore, reflection is nothing but it is the bouncing back of light when it falls on a smooth surface, and refraction is nothing, the bending of light wave when it changes material medium. From this experiment, what we understand, when light propagates from air to water, it bends. Since it is a wave, it bends. That means it bends towards the normal. Why it bends towards the normal? Because the index of refraction of air is less than the index of refraction of water. Or in other words, I can say that the optical density of air is less than the optical density of water. In general, from this simulation, we can say that when light propagates from a medium with a lower index of refraction to a medium with a higher index of refraction, it bends toward the normal. በዚህ ሲሙሌሽን ለማሳየት የሞከርኩት የብርሃን መንጸባረቅንና የብርሃን ከአንድ ሚዲየም ወደ ሌላ ሚዲየም ሲሸጋገር መታጠፍን ነው። እዚህ ጋር ለማሳየት እንደሞከርኩት እዚህ ጋር ላይት ሶርስ አለን። ይሄን ላይት ሶርስ ብርሃን እንዲያመነጭ ሳደርገው የተወሰነው ብርሃን በውሃና በአየር መካከል ካለው ባውንደሪ ላይ ተንጸባርቆ ይመለሳል። ያ ደግሞ እኛ ሪፍሌክሽን ብለን የጠራ ነው የዌቭ ኔቸር ኦፍ ላይት ፕሮፐርቲ ነው። የተወሰነው ብርሃን ካለፈ በኋላ ደግሞ ወደ ቨርቲካል ላይኑ የመታጠፍ ወይም የመሰበር ጸባይ አለው። ስለዚህ ብርሃን ወይም ደግሞ ላይት ዌቭ ብለን የምንጠራው ነገር ስሙዝ ሰርፌስ ላይ ሲያርፍ ወይም በሚያርፍበት ጊዜ ምን ያደርጋል? ተንጸባርቆ ይመለሳል። ያንን ፌኖሜና ሪፍሌክሽን ስንለው ብርሃን ከአንድ ሚዲየም ወደ ሌላ ሚዲየም በሚያልፍበት ጊዜ ይሰበራል። ያን ስብራቱን ደግሞ ሪፍራክሽን ብለን እንጠራለን። እንግዲህ ይህ ቨርቲካል ላይ ወይም ኖርማል ላይ ምን ለማድረግ ያገለግለናል? የስብራቱን መጠን ለመለካት ያገለግለናል። ከዚህ ሲሙሌሽን የምንረዳው ነገር ምንድነው? በዋናነት ብርሃን ለስ ኢንዴክስ ኦፍ ሪፍራክሽን ወይም ደግሞ ኦፕቲካል ዴንሲቲው ለስ ከሆነ ሚዲየም ወደ ኦፕቲካል ዴንሲቲው ሃይ ወደ ሆነ ሚዲየም በሚያልፍበት ጊዜ ወደ ኖርማል ይሰበራል ማለት ነው። ስለዚህ ይህ ሲሙሌሽን በዋናነት የሚያስረዳን የብርሃን ስብራትንና የብርሃን መንጸባረቅን ነው ማለት ነው።
Now let us see the wave properties of light called interference and diffraction. Before we see interference and diffraction, first let us see what is a wave. According to your optics and light lesson, a wave can be defined as it is a physical phenomenon produced by disturbance. The disturbance may be mechanical means or it may be electromagnetic means. A wave which is produced by mechanical disturbance is called mechanical wave. A good example for mechanical wave are a wave on a string or sound wave. For example, let us see here we have a string and this string is attached with a mechanical system. When the string is disturbed by this mechanical system, it produces a mechanical wave. Now, let me show you the simulation. Now, here we have a simulation. Now, the string is disturbed by mechanical means and it produces a wave. Such type of wave is called mechanical wave. The second type of wave is electromagnetic wave. And these electromagnetic waves are produced by electromagnetic disturbance. A good example for electromagnetic wave are light wave and radio wave. Now let us see here we have a simulation that will help us to understand electromagnetic wave. Now in this simulation, there are graphical user interfaces. This graphical user interface contains the black screen and the light source. When we push on the light source, it produces a light wave and the concentric or the circular surfaces that moves outward are called wavefronts. When we are talking about light wave, a light wave can be determined by wavefront or it can be determined by array diagram. Now these circular surfaces that moves outward are called a wavefront. So this wavefront is simply defined as an imaginary surface that join points on a wave that are in phase. Again, the direction of propagation of this wavefront can be represented by array diagram, and array diagram simply show us the direction of propagation of a light wave. Now, let us see what interference is. Now, here we have two light sources. Because interference is a combination of two or more waves that gives a resultant wave. Therefore, here we have two sources, and let us take, here we have a graph. First, let us see what will happen when we produce a wave by using a light wave by using the single source. Now, when we push this button on, there will be a light wave, and this light wave oscillates up and down as described in the screen or as shown in the screen. So when it moves up and down, it produces a zigzag pattern. So the peak points are called crest and trough. So the peak point which is found on the above part are called crest, and the peak points which are found on the lower part are called troughs. Now, when we add some other wave, when we add another light wave, so this crest and the trough increases because this result gives us the resultant of the two waves or the interference of the two waves. This is what the meaning of interference is. The other basic topic is diffraction. So as we have seen in the definition, diffraction is nothing but it is the spreading of a light wave at the corner of a given obstacle or when it passes through a narrow hole. Now here we have a black screen. Here we have two black screens. Now on the first, there is a white spot. The white spot indicates that a narrow hole, when light passes through this hole, After it passes the hole, it spread out and it covers all this surface area. This phenomenon is called diffraction. Now let us see, here we have a light source. Let us push the button on. When we push the button on, it produces a light wave. When the light wave passes through a narrow hole, after passing the hole, it spread out on the screen. This phenomenon is called diffraction. ለምሳሌ እዚህ ጋር የላይት ዌቭ ሶርስ አለኝ ወይም ደግሞ ምንጩ አለኝ። ይሄን የላይት ዌቭ ሶርስ በመጠቀም ላይት ዌቭ በማንመነጭበትና በትንሽ ቀዳዳ በሚያልፍበት ሰዓት በቀዳዳው ካለፈ በኋላ እዚህ ስክሪን ላይ እንደምታዩት በሰፊው ተሰራጭቶ እናገኘዋለን። ይሄንን የብርሃን ስርጭት በስክሪኑ ላይ ያየነውን የብርሃን ስርጭት ደግሞ ዲፍራክሽን ብለን እንጠራዋለን ማለት ነው። ሶ በቀጣይ we will see in our next part we will see the particle nature of light.
The second property of light is its particle nature. Although the particle nature of light was proposed by various scientists, it was solidified by Albert Einstein through his explanation of the photoelectric effect. According to this phenomena, when packets of light energy called photons strike the surface of matter, they transfer their energy to electrons in the matter. If the energy of the photon is sufficient, it overcomes the metal's work function, resulting in the ejection of electrons from the metal surface. This confirmed the quantized nature of light energy. In simple words, when we are talking about the particle nature, simply we can say that light is made up of particles called photons. Photons are discrete packets of energy that travel at the speed of light. The energy of a photon is related to the frequency of the light. That means the energy of a photon can be denoted by capital E, and it can be calculated by H times F. H is a constant and F is the frequency of the light. When the frequency of the light increases, the energy of the photon also increases. Now, in order to make it clear, let me show you a simple experiment. Here we have a source of light that can emit packets of energy called photon. When the photon emitted by this light source collide with this atom, if the energy of the atom is the energy of the photon is enough, then the atom, the electron, which is collided by the energy of the photon from the source of light, can be emitted from this atom. Now let us see the experiment simply. Now here we have a packet of energy or a photon of energy. This photon of energy is collided with this atom. The atom gains enough amount of the photon energy and it emits or it ejects a charged particle. This shows us the particle nature of light, and the name of this experiment is called the photoelectric effect experiment, and it is initially demonstrated by Albert Einstein. The other important point that we are going to see is sources of light. Light can be emitted from coherent or non-coherent sources. In the case of a coherent source, the emitted light wave have the same frequency, wavelengths, and maintain a constant phase relationship over time. This coherence is essential for producing a consistent and stable interference pattern. In contrast, light from a non-coherent source consists of waves with different frequencies, wavelengths, and varying phase relationship. This variability pattern prevents the formation of a stable or consistent interference
pattern. In simple words, the source of light can be classified into two: one coherent and two non-coherent. Coherent light source have the same frequency and wavelengths, maintain a fixed phase difference, maintain consistent interference pattern. In the case of non-coherent light source, have the different frequency and wavelengths, maintain a variable phase difference, again maintain unstable interference pattern. Now let us go back to our question. The question says, which one of the following statement does not describe coherent light or interference of coherent light? A, coherent light waves have the same frequency and wavelengths. That is true, because as we have seen earlier, if the source of a light is coherent, then it have the same frequency. The light waves have the same frequency and wavelengths. B, in order for two waves to be coherent, they must have the same type of wave. Yes, coherent waves are the same types of waves. Therefore, this is also true. C, sustainable interference pattern can be formed by two waves with variable phase difference. Now, the question is here. The problem is here. In order to maintain sustainable interference pattern, the phase difference must be constant. But in C, it says variable. Therefore, C is not correct. D, two waves which maintain constant phase relationship can produce sustained interference. That is true. Therefore, the answer for this question is C. Thank you very much for this question. Next time, I will come with the second question that will be taken from the Ethiopian Senior Secondary School Leaving Certificate Examination question number 2. Have a nice time.